Finding pattern rules can be a bit of a challenge. I mean, how do you know whether when you're looking at these input-output tables, you're going to need addition, or whether it's subtraction, or whether you need to multiply or divide? And then in some cases, none of these work and you have to combine operations. It can be tough. Well, here's some things I think about when I'm trying to figure out a pattern rule. Let's start with this one here. The very first thing I do is I start to look at the relationship between these two. And here I'm noticing that they're going up by the same amount. In fact, I notice that this goes up by the same amount as this. They're parallel, if you will. Here we have 6, and I think in terms of addition first. 6 plus 5 gives me 11. 7 plus 5 gives me 12. 8 plus 5 gives me 13. It's looking pretty constant. 9 plus 5 gives me 14. 10 plus 5 gives me 15. I know my rule. It's the input plus 5 gives me my output. That's my pattern rule. Well, let's try another one. How about this one? Again, I'm starting to look for relationships, and I think in terms of addition. 6 apart. Oh, no, that's not 6 apart. This one's 6 apart, but this one is 12 apart. And this one's neither of those. This one's 18 apart. So I know it's not addition. Well, let's try multiplication then. 2 times 4 gives me 8. 4 times 4 equals 6. Hey, I'm starting to get a little excited here, but I know that with my patterns, it has to be true all the way through, if it's really a pattern. So 2 times 4 is 8, 4 times 4 is 16, 6 times 4 is, I like this, I'm feeling pretty confident. 2 times 4 gives me 8, 4 times 4 gives me 16, 6 times 4 gives me 24, 8 times, I'm feeling like it's a winner, 10 times 4 gives me 40. I know my pattern rule. Input times 4 gives me my output. Well, we're feeling so good about ourselves. Let's try one more, all right? Let's try this one here. So I'm looking for addition, subtraction, relationships. How far apart are these? This one's 0 apart. This one's, oh, nope. 3 apart, 6 apart. No, it's definitely not addition, subtraction. These aren't growing at the same pace at all. How about multiplication or division? Well, 1 times 1 is 1, but 2 times 1 isn't 5, and 3 times 3 is 9, but no, that doesn't work. You know what? Even just a really quick look, and I know I have to find a combination of these operations. 2 of these operations are going to have to work together. Here's where I just try different things. I know it's not going to be times 1. Times 2, now if this was times 2, I'd have to subtract 1 here. 2 times 2 is 4. I have to add 1 here, so that's not going to work. Let's try times 3. 1 times 3 is 3, minus 2 is 1. 2 times 3 is 6, minus 1 is 5. No, that's not going to be consistent either. Let's try times 4. 1 times 4 is 4, and 3 away. 2 times 4 is 8, and 3 away. 3 times 4 is 12, and I'm 3 away. Hey, this is, now I want to chase down this a little bit farther. I think I'm onto something here. So I went 1 times 4, and that gave me 4. 2 times 4 gave me 8. 3 times 4 gave me 12. And you know what's encouraging for me about this? I'm noticing that these are all greater than my output. In fact, they're all greater by the same distance. 4 times 4 gives me 16. And 5 times 4 gives me 20. Now, this is 3 away. So if I subtract 3 here, I get 1. If I subtract 3 here, this is very encouraging. Look at this. Look at this. All the way through. Look at that. Now I know my pattern rule. If I take my input number and I times it by 4, all right, all the way along, times it by 4, and then subtract 3, always, always, I end up with my output number. It's true, there are no quick, easy ways to figure out these rules. It does take some perseverance. But if you think through your operations systematically, if you look at the relationships between these numbers, I think you'll have some pretty good success here. All the best.